So good day, everyone. Welcome to another class. So today we'll be discussing on the concept called arrays. Now, you remember that whenever we want to create variables in programming, yes, we have to define the data type followed by the variable name. So if I have to create an integer variable, so let's say score. So I just say score, let's say. So I've created a variable, a memory location where I can store a value. So if I have to store a value, I can then say, okay, 40. It means I've stored 40 inside a location called score. Now, what if I have to create a whole list, a lot of variable locations? Let's say I like to create like 1,000,000 location. So how do I create it? Will I have to start typing score 1 in score 2, score 3, score 4, score 9 on, that's a whole lot of work. And it's not possible for us to waste our time doing that. But with the concept of array helps you to create contiguous memory location variables. It helps you to create a lot of variables which are in contiguous memory location. That is to say, those variables are one after the other. They are stored one after the other. So with the concept of array would help us overcome those challenges. So how do you create an array in C++? So the same way you create variables, right? The same way you create variables, that's the same way you create array, but you have to specify the size. So with this, I've created variable locations or array of 10 variables. Now, all of them will have the same data type called int. They all have the same data type called int. And this is a list of 10 variables. Now, how do I access individual variable location? I have to use my index. I have to use an index to say, oh, score of location 1, score of location 0, score of location 3. It's just like in our everyday, if we have to create a drawer, then with this, I've created an array of, of lot of spaces. So you can have the first drawer, second drawer, third drawer, whatsoever, and lot of drawers like that. Now, how do you access the first drawer? Then you have to specify the name of the array, followed by the index. So one thing about array is zero index. It means the first array element has the index of 0. It has the index of 0. So for me to access this location, I have to say, oh, score 0. So it means score 0. It means I'm referring to this location. Then I can put a value there. I can say 5. So it means I've been able to place 5 in the first variable location. The next variable location, I'll say score of the index of 1. Then I can now access it. I can put a value in it. So it means arrays in C++ is 0 index. The first index is 0. The last index will be the size minus 1. So for this, it means I've created 10 variables location whose first variable has the index of 0. The last variable has the index of 9. It has the index of 9. Right. So that is how you access those locations. So let's code. So I can just come here and say, okay, the one of index 0, the value should be 10. The position of index 1 should have the value of 200. That is how you you do with array, right? So individual positions, you start giving them value. It's just like a house with many flats. So the flat number 1, flat number 2, flat number 3, you're accessing individual flats, and you can store or get a value from it, right? So with this concept of array, I've been able to store values in just 2 locations. We still have 8 locations left. Now you can access any location you want. It's not necessarily you have to access the location, sequentially. So you can see with this, I've been able to input value in those 3 locations. For me to display the content in the array, I have to also specify the location. So with this now, I'm saying, okay, display to me, for me, the value in the location 0. So let's see, we expect to see a value of 10. We expect to see a value of 10. So let's see. Yes, we have a value of 10. So if we want to check the location 1, so we should see, we'll see the value of 200, right? With that, you can see, with that, we've been able to. Now, we can also do some arithmetic and say, okay, the location 8 is equal to the value in location 0 plus the value in location 1. So with that, we can check the score, the value in index 8. So we expect to have 210. Let's see. Yes. So that is the concept of array. Now, the issue is, what if I have a large array size? I have a large array size. Then how do I have to be inserting individually like this? Then I can use a for loop. A for loop will help you traverse every location in the what of the array. So what you can also do is you can create a variable called I, or it can be count, right? You can just come and say, okay, for when I is equal to 0, so when I is less than 10, because we know that in the array is 0 index. The last array location has the index of 9. So I is less than 9, less than 10, or you can say I is less or equals to 9. Anyone you feel like. So with the index, so with this, I can specify that score with the index of I. So I will be used as our index. So when I is 0, you are assessing the score of 0. When I becomes 1, assessing the score of location 1. When I becomes 2. So you can see that the I serves as the counter or as the index to traverse. So I can come here and just say I times 2. I times 2. Okay. Now I times 2 should be stored there. So you can also use the for loop to display the results. So how do I display the result? Use the for loop. And also use I as the index. And also use I as the index. So with this, I've been able to, let's see our result. So when I is 0, 0 times 2 is 0. When I is 1, 1 times 2. When I is 2, 2 times 2, 4. When I is 3, 3 times 2. So you can, that's how you use the for loop to access individual array location, right? So like I told you that array are stored sequentially. Array are stored what? Are stored sequentially, one after the other in the memory location. So how do we see the location? So what we can do is we can specify that, okay, the variable, you can just say variable followed by address, followed by the address. So, okay, so we can display score of the index of I followed by the address. So how do we get the address of a variable? Use the ampersand, score of the index of I, end line. So let's use for loop for I equals 0, for I equals 0, yes, I less than 10, I less than, or we can do this, I less or equal to 9. It's still the same. Then we can do I plus plus. I plus plus. So with this, we can find the variable followed by the address, the variable score followed by the address. So you'll be able to see that the variables are stored, they are stored sequentially. Okay, so let me format it better. Oh, sorry. Let me format it better. Yeah. Let's see. Okay, let's see. Let's see. We'll be able to see variable followed by the address. So you can see the address. So they are stored sequentially. When you look at the address, you can see that this is an hexadecimal address. So for in hexadecimal, you know that you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 10 becomes A, followed by B, followed by C, D, E, F. So hexadecimal means 16 digits. 16 digits. So F is 15. Yes, so after C, you know that integer stores values in 4 bytes of memory location, 4 bytes. So the first array location ends is D1C. D1C. You can say D1C, the last is C, add 4 to it, 4 locations, D, E, F, 0. So you can see it's more like a counter. So when it gets to 0, it increments the next number to 2. So 2. From 0 now, add 4 bytes. The next memory location, 1, 2, 3, 4. So you can see the next is 4. From 4, add another 4. You can see. So you can see that they are stored in contiguous memory location. They are stored in contiguous memory location. You can see the reason why it's 4 is the size of those variable. The size is 4 bytes. Why? Because they are declared after ints. So let me show you how to also dictate the size. So we can also get the size. We can also get the size. How do we get the size? We can get the size by using size of. See out the size in bytes. To get the size in bytes, we can say the size of the array in bytes. In bytes. So in bytes. So we use the keyword size of. Size of what? Size of score. Size of score. Size of score. So with this, you'll be able to see the size of the array. The size of the array. So the size of the array in byte is 40. You can see the array is 10, but each individual location is 4 bytes. So 4 times 10, that's 40. To really get the size, you can actually divide the size of the array, of the entire array, by the size of integer, by the size of ints, by the size of integer. Size of, the size of integer. So then this will give you the real size of the array. The real size of the array, which is 10. You can see the real size of the array is 10. All right. All right. Okay. Another thing I would like you to know, is that when you try to explain just the name of the array, display just the name of the array, it will give us an hexadecimal address. It will give us an hexadecimal address. So just displaying the score, it will give us an address. Yes, and this address is the same as the address of the first array location. So how do you get the size? The size of the first array is just like this. In array, we know array is a contiguous memory location. So if you can get the size of the first array element, then other size, other memory location are just they just differ by a number. They are just a point away. Okay, so let me just display and show that the size of the array and the size of the first element are the same. Okay, I think I'm having. Okay, the address. Yes, we can see that the address is the same. The address is the same. Now we can use the concept of a pointer with array. So I can come here and declare a pointer and say, okay, I'm a pointer to an integer, right? So I'm a pointer to an integer, so I'm pointing to score. I can point to score. If I'm pointing to score, it also means I'm pointing to the location of the first array, right? So this pointer is pointing to the location of the first array location. Yeah, first element. You can see we've been able to do that. Then while the pointer. So let me just do this. Call of the index of 0 to have a value called 20. Then I can come here and say, okay, let me copy this. Of 1 equals 200. Of 2 equals 120. Of 3 equals 250. Okay, so this pointer is pointing to this first location. So with the pointer, you can actually see the contents of where you're pointing to. Since I'm pointing to score 0 of the index of 0, then I can actually get the value of what the pointer is pointing to. The value of the array, the pointer is pointing at is so with now I've referenced the pointer is pointing to score 0, the address of score 0. It means it's referencing score 0. Then we can dereference. We can now get the value by doing this. You can get the value of where the pointer is pointing to by dereferencing. So if we look at the array, we said, okay, the entire array is called core. The entire array is called core, right? So the index of 1 has the value of 20. The index of 2 of 0 has the value of 20. The index of 0 has the value of 20. The index of 1 has the value of 200. The index of 2 has the value of 120. Has the value of 120. Index of 2. The index of 3 has the value of 250. So what I just did is I created a pointer variable, a pointer called PTR, and it's pointing to score, to the address. So when it's pointing to score, it's actually pointing to the address of the first score element of the index of 0. So it means I can get a value from that location, right? So let's display what the pointer is pointing at. The value of the array the pointer is pointing at is 20. Yes. I can use the dereferencing, the asterisk operator, which is used to reference, saying, okay, I'm pointing at score, the address of score 0. Then with the dereferencing, I can actually get a value from it. So for me to get the value, I use the asterisk followed by the pointer PTR. So what I can actually do again is I can come here and do what we call pointer arithmetic. I can increment the pointer So if I increment the pointer will no longer point at 0. It's now pointing at 1. The address of index 1 is now pointing at this with this pointer arithmetic. So let's see the value where the pointer is pointing at. So previously it's pointing at 0, score 0. Now we've incremented the address to point at 1. We can now get the value of what it's pointing at. So let's see what the pointer is pointing out, the value in that location. So it should give us 200. Yes, it's now 200. So with pointer arithmetic, I can come here and just say PTR plus equal to 2. Plus equal to 2 means I increment it by 2. So I was pointing at 1 now. Plus 2 means I'm going to the address of 3. So with that now, I can actually print the value. So I should have 20 followed by 200 followed by 250. So let's see. Using the concept of pointer and array. Yes, 20 followed by 200 followed by 250. So you can see how to use arrays, how to use pointers with an array. We've also been able to clearly show that array variables are stored in contiguous memory location. They're stored in contiguous memory location, and that's awesome. That's awesome. So I also want to discuss about floats. The same way for an integer, also that's the same way for a float. All what you just have to do is to change the value. Then you can also see that we're having an error there. Why? Because the pointer must also have the same data type as where it's pointing at. So we can come here and say .05 .56 just to 443.22. So yes, it works. Reka. Okay, so the other thing I need to show you before we end this class is I need to show you about character, array of characters. Okay, so let me call this char. Let me call it name. So character name. We all know that a character can just store just one alphabet. Just one alphabet. Let's just show that. Okay, so when you say in name, that is to say you want to input the value that it should be saved in name, and let's display the content of name. Let's display it back. Immediately we'll do that with type. So it's asking us to input a name. So let me just type a day and let's see what will be displayed. You can see, oh, sorry. We've deleted the system pause. System pause. It helps us to pause the screen. Okay, so let's run again. Let me just type a day and press enter. You can see that it's displaying just A for us. It's only displaying A for us. Why? Because a character can only store any variable stored created with a character data type can only store one character. But now the question is, in essence, in life, we want to store the name of a brand, the name of a person, the name of a thing, a location, whatsoever. So a single character will not suffice. We need to have a lot of characters. So we can also create using the concept of array. We can say, okay, if I want to display Lagos, if I have to display Lagos, so I have to create an array. The first index of location will store L, the second will store A, the third will store G, the store O, and the last will store S. So with this, an array of character, we can actually have a meaningful string, right? So let's see that in practice. So now I have to use my index and just create, let's say 10. Let's say 10. And let's see what will happen when I want to type hard day. So it accepts. It accepts. So you can see that with the concept of array, you can store a whole lot. Now, let me also show you one more thing. Let me type address. An address is just 20. Okay. In real life implementation, you have to specify larger index, the size, so that you'll be able to store more characters. If the name of a person is long or the address is long, you will not expect to use an index of 20. If it's very long, you might specify 50 or 100, right? So let me do this. Let me do this. Please input your name. Please input your name. Okay. And line. Okay. So the person will input and also display the name. All right. So let's also do this. Please input your address. So the person have to input the address and display the address. Okay. All right. So let's see what we have. If I have a day, you have to be conscious. A day. Okay. Let's just say this. Now, yes, it displays. Look at the error we are having now. Look at the error we're having. Immediately, I ask it to input my name. I was able to type in my name. And as I type in my name, it displays just a portion of the name, before white space before space, right? It shows Adenola leaving the knee. Now, after leaving the knee, it does not allow me to input the address. So the remaining knee is now, saved in the address. Then there's an issue we can't input our name, we can't input our address, and the full name is not there. So what can be done? Where does the issue lies? Now, the issue lies with the class called scene. The issue lies with scene, the class called scene. Using scene, now I want you to see that every time we are typing, we are typing into a string. Let me so imagine this is our CPU. This is our CPU. This is our keyboard. And this is our screen. This is our screen, our monitor. Okay. So the CPU is connected to the monitor. The keyboard is connected to the CPU. So this is the CPU. All right. Okay. So anytime I use the keyword scene, so cin, so to accept input, you can see the in to accept compiler accept input. So any input I receive from the keyboard will flow like a stream and be saved where a name. So the name is stored in the CPU. So when I type A, imagine A flowing like a stream, on a stream, see A as a leaf flowing on the stream. And A comes here, D, I type D flows like a stream, save here. Now, after I type the whole adenola, the issue with cin is when it sees a white space bar, when it sees the white space, it stops accepting input. So the remaining ni, which I type, is still in the input stream. It's still in the stream. It's still here. It has not been flushed. So the ni is still in the stream. The next time I want to accept input, it wants to accept input from the keyboard, it's the remaining part of the letter in the stream will be saved where? Will be saved in the next variable location called address. So address now has the remaining part of the name which is in the stream is saved there. So the address. So anything, you can see it did not allow me to type, it flows into that location. So how can we go about this? How can we see that we don't have any erroneous inputs whatsoever? So the way out for us is to use a modification called cin.getLine. So we use cin.getLine. So cin.getLine is a method in the cin class with you specify the name. If you look at it, you specify the name, you specify the stream size. So the stream size for name is 10. The size for name is 10, followed by a comma, you can see, followed by a character delimiter. Delimiter means what it sees and it stopped working. So our delimiter is our /n, which stands for new line. /n, which is our escape character, stands for a new line. It means when I finish typing and I press enter, enter means /n, it should stop. So it will accept all the inputs, all the strings of characters till it says enter, right? So also now the beautiful thing about this get in method is any character that is still remaining in the stream, any character in the stream that is still remaining will be flushed. It will be flushed. So let's copy this and let's do that for address. Let's do this for address. So the size of the address is 20. So let's see what we will have. Let's see what we have. Input your name at the me. Now input your address. So we need to flush. Okay, let me see again. I think we exceeded our size. Our size is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the /n, there's something called the not character. So it will accept 9 character. The last one, which is +0, which is the not termination. So let's just type ade nola adenola. So it displays, we can now display our address. Unilag. You can see it displays. Now, with that, we need to use our flush. We need to flush the system. Can I still remember how to flush? NES, I think is saying .flush. Let me see. Flush. Flush. Sure. Let me check. I'm not seeing. Let's see all the methods that we have. Clear. Okay. Okay, I think he's saying .ignore. Ignore, yes. Saying .ignore. So we have to specify the stream size. Okay, let's say ignore. Ignore stream count. So let me just do this. Stream count followed by delimiter, meta delimiter. Okay, let me just do this. Let's see what it would perform. Let's see if it will clear scene.ignore. I know scene.ignore will flush any name, anything remaining from our queue. Let's see. Let's just see. It's good. Yes. It did not allow us to input our address. Sorry. Okay. Let's see. Scene.ignore. If we are having excess, I just want to see if we're having excess character. Okay, so let me see how to clear how to clear, how to use scene dot ignore in plus plus. Let's see how to use it. Okay. Optional, optional. Let's just try scene dot ignore without scene dot ignore. Let's just see. I just see. Well, learning. So I know I would like to give you um okay, followed by determinant. Okay, so you can just find um how to ignore. Yes. Okay. Okay, let's see. Although we've gotten our result, but I just want to see how we can resolve SS value in the queue. Okay. Mm, yeah, I know there's a slash, there's an enter key, in the queue. That's why it's three. Let's try three. Let's see. Okay. So I think I will look for how to flush by not seeing dot ignore works. Seeing dot ignore works. So it's flush Ulysses this. I wonder why. Okay, let me just start. Okay. Okay. So sometimes we use the keyword, the class string. So it helps us resolve all these, right? So string dot get line auto flush any strenuous character in the queue. So I would like to find out why we're having these issues. Okay. Okay. So that is taken care of. The last thing we can also learn before we call it a day is what we call multidimensional array. So we can create a multidimensional array. The first one we looked at is just single dimension. Single dimension in the sense that we only create an array with a single column, right? So it's single column but many rows, right? But with this now, so with single column, right? So many rows. So but with this, we've been able to create two-dimensional array. So it's more like rows and column. So two rows, two column. So these two rows. And you know it's zero index, so it means the zero row followed by one. This is the row one, row two, column zero, column one. So if you are, so it's most of the time, or a lot of time, array is used for board games. Board game, let's say checkers or draft whatsoever, or chess. Board game where you have dimension like 8 by 8 dimension. So the board, the players are in 8 column, 8 row by 8 column whatsoever, right? So with this, if you have to specify location, you have to specify both the rows, yes, and the column. So arrays, multidimensional array like these are also used in, they're also used when you're looking at matrices and when you're looking at data, a lot of data, right? They're using. So what can we do? We can actually um, input value into this location, right? So you can just say name, You can just say name. Let me just copy this. So you can name 0, position 0 equals what character? Let's say this. You can use it to play a whole lot of game, right? So what we're doing is in this dimension, this location, you put a value of O there. And copy, paste, and say, okay, here index 1 should have X there. See, so you can say 1, 1. So it means here has 0x, 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 0x. So you can also use a matrix. In matrix, you want to determine the determinant of a matrix to multiply the adjacent row followed by the adjacent minus this. So what you can actually do, what you can also do is this. We can change the data type to, let's say, int, matrix. You can just do int matrix, and then this has the value, let's say 10. These are of the value of 2. These are the value of 3. These have the value of 4. Then for you to get the determinant, let me say to get the determinant int, then to get the determinant, you can say name in position number this. So it means this location times 1, 1 times 1, 1 minus 0, 1, 0, 1 times 1, 0. Sorry. So it means, oh, sorry. I call it matrix. I should have changed the name. Okay, let's just say name. So it means you multiply this column, this adjacent position followed by this adjacent position. And then let's say that's it. And then you can see out your determinants. You can see out your determinant. So we have 2-dimensional, 3-dimensional, 4-dimension as you want it. So let's run. So we have 34 as our determinant. So it means this times 1, 1, that's 40 minus 6, that's 34. So you can manipulate those positions and apply it in real life. Okay, so today we've been able to talk a lot about application of array, right? So we'll see in the next class. All right.